what sort of data we will be dealing in real life, and why we need basically scaling for machine learning or artificial intelligence. Then I will give an overview of the machine learning framework, what's the basic design cycle, or how we go ahead, solving a problem using machine learning. And then we will come to the main topic, or main topic like about distributed processing, and how this distributed processing actually helps in solving machine learning or artificial intelligence problem, and why we need that. And later on, at the last, I'll give you a brief overview of our upcoming course on machine learning with Spark. So let's start. Okay. Who am I and what I'm doing here? Of course, Dr. Adnan already introduced me. So my name is Mohammad Amjaroza. I have done PhD from University of Melbourne. I've been working in various industries as a data scientist, or data engineer kind of thing. Okay, so what is .ai? Actually, this is very common domain name these days, and this is not actually a random domain. This domain is owned by a country called Angola, and is administered by that country. So because of artificial intelligence, that domain is very popular and very expensive. You should know that. Okay, AI is not new. This is fact. Yes, I'm sure this is not new. And the hot news of the today: Elon Musk has become the world's richest person, as his net worth crossed 185 billion, just because their Tesla prices increased a lot yesterday. And why Elon Musk is relevant to us? It is because he's one of the visionary person who believes in artificial intelligence, and he believes in technology as well. Okay, so bigger picture of the problem. So in our today's discussion, what are the important points? So one of the major important point is our data. So we're going to talk a lot about the data, and we are going to talk about a lot, our data is huge. For that, we need data storages, and we need cleaning and processing, and do a lot of things about the data. And the next part is machine learning or artificial intelligence. We have to process the data according to our machine learning frameworks. We learn about or talk about building models, training models, how we test our model, and how we deploy our model. And while deploying our model, the scalability is comes when we train the model, we test the model, deploy the model. So everything is kind of interrelated here. Okay, so what's our objective? So in this case, our objective is uh, we want to understand or build a production ready, scalable machine learning or artificial pipelines for big data. So this is a core objective of our talk today. Let me give you an overview of the life cycle of machine learning using distributed platform. We'll talk in detail later on. Just to get prepared what's coming in the few slides, I'll give you an overview here. So at the first stage, we capture the raw data using different technologies. Once we capture the raw data, what we need to do is we need to prepare the data, clean the data, pre-process the data. So I assume a lot of people already know about pandas, sklearn, and some people must know about Spark as well. So this is a distributed framework as well. We will talk in detail later on, and koalas. So I'll introduce koalas as well if you don't know. And the next step is this part is our machine learning. So machine learning comes in a is pretty much standard these days using sklearn. If we go talk about artificial intelligence or deep learning, we have to talk about PyTorch or TensorFlow, and of course Spark as well. And the next step is deploying. So deployment is very important topic as well, because we want to scale or scale our model so that global customer or client can use the model and it can bear the load. So here we need scalability as well, and there are a lot of different technologies to deploy our model as well. Okay, so let me briefly talk about what is machine learning and artificial intelligence. So machine learning is basically finding a relationship of the data using the data. So what we do is we provide data to our machine learning algorithm, and it learns the relationship and give us a model. So that's pretty much simple definition of the model is. And in this case, the data is the key starting point, and the quality of data is important as well. There are a lot of different libraries, open source libraries existed, and people are using them a lot, and it's very active development area as well. For example, sklearn, TensorFlow, PyTorch, PyCaret, and a lot more. For the past few years, AutoML frameworks are getting a lot of attention as well. There are a lot of different frameworks developed by Google, Amazon, and other open source as well, with the scaling option as well. That's to see. Okay, so application of machine learning, I think I don't need to tell you about the application. There are a lot of applications of machine learning happening all over the world. In fact, all the businesses are trying in some way to get on the board and use machine learning or other data centric solutions for their businesses. Okay, so now what's the word artificial intelligence? As I said, artificial intelligence actually is very old a word, but due to some reasons or difficulty in computations, it couldn't get a lot of attraction it deserved or it's getting today. So how would I explain or define artificial intelligence? So I would say it's a machine learning technique, but using the intuition of human brain. So that those algorithms which using the intuition of human brain, that's basically comes under artificial intelligence. There are a lot of applications of artificial intelligence. So if you start with artificial intelligence, the one of the simplest algorithm that comes into anyone's minds is the neural networks, and that's basic of our deep learning as well. And so in neural network is that we define the network, and the network is learned by the data. And of course, as I said earlier, in case of machine learning or artificial intelligence, the quality of the data is very important, and we have to basically decide how much data we need and how good the data is. So I can say here that in order to train a network, we need huge amount of data, and for that we need computation sources, we need distributed computing, and a lot of different technologies we need in order to achieve our goals. Okay, so uh, let us learn a little bit about data platforms for our machine learning or AI algorithms. So as a first step, is very common. We have a data generation module. In this case, data is being generated at a very rapid speed. Even when right now we are talking, there are a lot of data is being generated from different web apps, clients, and various sources, uh, as text, pictures, videos, tabular, you name it. There are a lot of different sources of data available. And when we talk about data generation, this is the raw data generation. We cannot use this data as it is. We have to do a lot of things before this data is actually usable. Okay, so the next step is data cleaning. When we get the data, we want to clean the data or trying to understand the data, and also we need some auxiliary data to make sense of the data for some problems. So data governance is very important concept. When we actually capture the data, we want to make sure the data we are capturing is authentic and we can use it. There are different models. You develop some models around implementing some policies about the data governance and getting rid of some outliers to make the data relevant to our problem. Okay, third step is data storage. Okay, so data storage is one of the critical step in our systems at scale. We have a lot of different databases, or we have to develop data lakes, and we have to decide what sort of data storage is feasible for our problem, or is compatible with our framework. So for example, we have different data sources, formats, HDFS, we can pickle it, their binary resources, CSVs, relational databases, and so many other formats. And when we want to store the data, we have to decide whether the data is being stored locally or we need cloud storage. So it depends on our solution architecture, what sort of architecture is suitable for that particular organization or to solve that particular problem. So next step is data ingestion. So once we store the data, what to do with the data? So we, of course, we want to build a model using the data, and we have to prepare the data which is compatible with our machine learning framework. And since the data is very huge, it's almost impossible to load whole data in the memory and build the model. So we have to develop some solution which can help us loading the data on demand, and using those different what you would you say techniques, we develop our extract, transform, and load pipelines. So for when we build a solution for scaling purposes, we have to basically understand a whole lot of operations going underneath the data pipelines. Okay, so now let me briefly explain the overview of the ML framework. So how this design cycle of a problem using machine learning works. As a first step, we of course we want to do some exploratory data analysis. We want to understand the distribution of the data and try to develop our understanding. Can we believe on the data itself, or if we do not believe, and we find that at the end of our whole thing, the whole process is useless. So we're trying to understand the data at the first, and if the data is good enough or it can help us in solving our problem, we can go ahead and go to the next step, which is we call this feature engineering. So feature engineering is basically trying to understand your data a bit better, and trying to find a better features, or trying to decide what sort of target you are going to decide, and what's the relationship between target and your feature is. We're going to talk about feature engineering a little bit in detail in the next slide. So we prepare the data for the model. Depending on our choice of machine learning framework, we have to prepare the training, validation, and test data sets. We have to deal with some missing values and some other logic, or if we have to create more features, or apply some what you call any PCA or feature reduction methods, we deal with that here as well. So once we have data prepared, we want to train our model. So training model is because we can get a lot of implemented model out of shelf, and we can plug in our data, we train our model, and decide the best optimal model for the production. We save that model. In the next step, we deploy the model for production. So again, as I said earlier, when we deploy the model, it can be either on cloud or on your own server in-house. And it's very important that your solution or the deployment solution has to be scalable, because you can have millions of requests per second or per minute, depending on your service or your clients. So this solution has to be scalable as well. Model training has to be scalable as well. I will explain why in next few slides. Okay. So our job is not done. Even if after successfully deployment of our model, we have to keep track of the real performance, and we have to tune the model if we need to, or if the model is behaving terribly bad, we can take that offline. Okay, feature engineering. Let me briefly explain about the feature engineering. So in feature engineering, what we do is basically we try to understand the size of the data. We identify the target variable. When I say target variable, is actually our target of interest, or the variable we want to estimate. And we study the relationship or the distribution of our target and other features. We apply different transformations or feature reductions, and all those things we apply in feature engineering. And next step is the when we do feature engineering, we want to understand our problem as well and trying to deal with missing data, or we have to encode text or any other data, because all the machine learning algorithms, they only understand numbers. So we have to encode every text or any other thing into some numbers. Okay, so how we prepare the data for training? So we usually we have three sets of data. So we chop off our data into three sets: training set, validation set, or test set. So training set, we usually, it depends on the problem, but most of the times we do 80 and 20 thing, like 80% training data and 20% we leave it for the test data or unseen data. When we prepare our training data, it's very important that we have to be sure that there is no future information leakage is happening in the data. Otherwise, your model won't be able to learn. It's a disaster. And almost in every problem, we have to be very careful with this thing. In the validation set we use to validate our model. These two data sets comes together. So third one is the test. So test set is our unseen data, but of course, to test our model out of sample, but we have to make sure that this test set is a representative samples of our whole training set. So in other words, that the distribution of all three data sets has to be the same. Okay, so now we come to another important topic to understand about our multiprocessing versus distributed processing. So one can say that instead of distributed process, what's the difference between distributed versus multiprocessing frameworks? So I try to explain a difference here. So multiprocessing, uh, setting up a multiprocessing framework is has a lot of overheads. It's not optimal. Often you come up with a lot of issues. It doesn't have issues. We do have Python multiprocessing libraries. Issues, it's not scalable. It has very bad memory management, and also the resources are not fully utilized. So there are some example of the packages implemented in Python. We have multiprocessing, we have Fiber by Uber Engineering, JobLib, and there are many. So distributed processing, why we need distributed processing? So distributed processing is a native solution for parallel processing or multi processing, and is one of the best solution available. It does have better task distribution or management, and it does have scalable properties. Issues, uh, there are a little bit time needed to learn these tools and infrastructure building. Some of the times we do get some issues in debugging in case of distributed processing, because your code is running on different machines, so it's hard to debug. Example, one of the earlier solution, MapReduce. Spark is a uniform solution. We get to in detail in the next few slides. And Hadoop is most of the time is a storage layer for a distributed processing, or at least my choice.
Yes,
Okay,
Arjun.
is there any question or? Okay, so why we need big data platforms? Of course, we want to go for the distributed data processing, because the amount of data is huge, and simple computer or simple process we cannot handle using simple computers. So we have to go ahead and develop some distributed solutions. For that, we need distributed storage as well, because it helps in loading the data on demand. Distributed processing, there are a lot of different frameworks available for distributed processing. It does have better memory management. One of the example of the distributed processing is Scala. Scala is written for specific purpose of distributed processing, and Spark is a distributed framework for this one. Okay, so next thing is how we can use distributed processing in our machine learning and why we need that. So One of the key use of distributed processing is in our feature engineering, because we have to deal with huge amount of data, and to do the transformation, or even do the simple task of finding the distribution of the huge data is not easy. So we have to use distributed processing techniques to do feature engineering or feature or data processing. And when we do the training of our data, it's not easy to train, because it takes a long time if you happen to experience that thing. And if your training is broken in middle in after some times, to restart, it starts from scratch as well. But distributed machine learning training, it can start from a restart whenever it breaks. So this is one of the beauty. And if one of the cluster or one of the node is down, so the manager can assign those tasks to other machines as well. Okay, so another use of distributed processing is in deploying the model. As I said earlier, when we deploy the model, we expect a huge amount of traffic, and to handle that traffic, we need dedicated or better solution. So distributed processing can help in that area as well. Okay, so I think we have mentioned Spark many times so far. Let me introduce what the Spark is, and how can it help us in our machine learning framework. So Spark is a unified computing engine. It can run on local versus cluster mode, and you can scale up your cluster. You can add more machines or more processing into it. This is one of the most actively developed open source project. And Spark, when we talk about distributed processing, Spark is a de facto name. So it's one of the a standard name for distributed processing these days. Distributed machine learning and artificial intelligence. Spark has a machine learning library called MLib. You can use that library to basically leverage the distributed processing and train your models. In case of deep learning, most of the people, if they happen to use TensorFlow, it does have a module to train the models on the Spark, or even serve the application using Spark. uh, Also, the on-demand resource management for training and deployment can be implemented using Spark. Spark uses okay, so basic architecture of Spark. So Spark has some low-level layer. So in this case, they need to know about the Spark session, RDDs. So these are kind of what you call this data layer thing. And we have Spark context. If we go to the one layer up, so we have data sets, data frames, SQL. And here in the next step, we have different applications in the Spark. Spark can handle streaming, it can handle graph computing. There are a lot of different libraries or packages for our benefit. If we want to know about these languages, it can handle, you can program using Java, Python, Scala, or R. And different libraries can, there are different APIs written in Python, Scala, or R for data scientists or other users, if they don't want to actually write in Scala. By the way, Scala is the native language in which Spark whole framework is written. Okay, so uh, let me briefly give you an overview of how can Spark implement a machine learning pipeline. So here, as I said earlier, so this is our extract, transform, and load technique. Here we can capture the raw data using live or storage or anything. We can structure the data. We can transform the data using Spark. And in the next step, we can use Spark functionalities to explore the data, trying to find the distribution of the data or any other data exploration techniques. If you want to happen, you can use here or implement here. So the next step is a machine learning. So machine learning Spark has Python API, and its package is called PySpark, and it does have a sub module or sub package called MLlib. It does have a lot of different features engineering algorithms in for classification, regression, or any other machine learning techniques. So you train your model and you save your model for your production. So when I say production, means that you want to serve your model for the masses. Okay, so let me briefly explain what sort of technologies are being used in case of building big data platforms. So, of course, more than 90%, if I'm not wrong, 90% people is a must to learn and to serve your repo or build your repo. People use GitHub or GitLab. I like GitLab because you can host your GitLab instance in-house, and you can manage that server by yourself. And apart from that, Python is a core for developing big data pipelines, at least to start with. This is I think at least this is my personal favorite, and you need a few plotting tools to learn. Of course, to develop your pipelines, you want to understand first, and Jupyter can help us a lot in that case. For distributed processing, Spark is a must, and for data storage, I would say Hadoop is the must. So few tools here. I have mentioned few tools here. sklearn, I think most of the participants are familiar with sklearn to some extent, and TensorFlow as well, and Qualas. So basically, Qualas is a library which is written as a replacement of pandas, not as a replacement, but as in like a pandas to use Spark as a backend. So people can use pandas or Qualas. It does have similar functionalities. Pandas doesn't use Spark as a default backend, but Qualas use a Spark backend as default. Okay, so there are a lot of AutoML framework getting attraction as well. So probably you want to explore these AutoML frameworks as well. Okay, applications. Okay, so this slide is I have listed few applications of AI or machine learning with Spark, or scalable applications. So one of the key. Okay, so the first applications I can think of, because of my experience, is a stock market or the financial data. So when we talk about stock market, the data is being produced on a tick level. It's a huge amount of data, and if you want to build a model using the tick data, it's almost impossible these days to develop a model, because there are a lot of different markets, a lot of different sources, and if you have to build the model using all the data, I think you have to go ahead with the distributed framework, whether it's Spark or any other framework, and then you can apply a machine learning techniques to build a model. The second application you can think of is in computer vision. For example, one of the key application is image classification. So in image classification, the data is huge. If you have more data, and you can train your algorithm very well, and most of the best classification algorithm these days, they are based on TensorFlow, and you want to train your model for days and days, and for that you need a scalable framework to even train the model, and then serve your model. This one. Okay, so the next step is pre-processing your text data. NLP, natural language processing. This is a key topic for the last I think 1 year. are so. And if you think of application of NLP, it's huge. It's huge. You have to deal with your text data, whether it's your tweets or your WhatsApp messages or any other social media messages. It's huge. You have to develop models to understand all these traffic or trends and all those things using NLP, and to handle that amount of data. I think there's no question to ask whether to go ahead with scalable solution or not. So GPT-3, if you know this algorithm, I think Elon Musk is involved here as well. So they used a lot of text data to develop a model. So that solution is a distributed solution as well. And one of the key application could be developing your outlier detection system. It could be whether text data or tableau data or any other data. And this solution can be on the online feed, or even the stored data. So developing outlier detection on the live system, your system has to be scalable as well. Similarly, for the recommendation system, these are very common system as well. And these systems must be scalable as well, because you have to make decision on live, and your algorithm must be training on a frequent basis. Okay, so retail analytics. So this is another key areas where a huge amount of data is being produced and processed to decide about your supply chain, racking the stock, sales force cost, customer behavior, and all those different things. So I've mentioned a few applications. There are many applications of AI or machine learning where we need basically a scalable solution. Okay. Uh, I think it's important as well. I have listed few learning resources. You can Google a lot more. So you can go ahead on this link, which is basically a Microsoft AI at scale. Even Google has some trainings on at the scale as well. Amazon and other as well. Spark is one of the key I think framework to learn if you want to know more about distributed processing or develop solution on scale. Of course, Python, I shouldn't mention that, but it's there. And Kaggle is a good source. You can go ahead and apply your skills on a real problem, and try to solve a scalable solution. Okay, so Databricks. So what is Databricks is basically a Spark de facto cloud solution. So it's a good resource. I must recommend this as well. If you want to learn more, you should go there. I think that you can sign in as in demo account or free account, and get your hands dirty on a scalable solution. Okay, so let me briefly give you an overview of the upcoming course on artificial intelligence or machine learning with the Spark. So what this course would be, this course would be more as in hands-on course, and like 60% hands-on, 40% theoretical. And we will be learning some cutting-edge technologies. We will be dealing in Python, and we'll learn Spark as well, and machine learning with Spark. We'll be using a lot of different open source libraries. As regard to the working environment, we'll be using Google Collab. So our environment is similar for all the participants. You don't have to basically set up your computer for these things. And for each week we will have a challenge. In the week one, we will be learning about introduction to Google Collabs, and getting started with the Spark. In week two, we'll learn about data processing, pre-processing, and we'll have introduction about koalas as well. Week three, week four, week five, we will solve machine learning problem using Spark. So week six would be optional, or kind of a brainstorming session. The reason for this week is because I'm a believer that you have to solve a real world problem. See, after learning all these things, I would encourage everyone that they find a problem, and they solve that problem to get a better understanding of what they learned for the previous few weeks. Okay, so that's end of my talk. One last thing, that's my personal. Asking a right question is an art. In my opinion, right question contains half the solution. So here's my LinkedIn link. Happy to connect and happy to answer any of your questions. Yep.
Okay, thank you, Dr. Amjad, for your wonderful presentation. It was really insightful, and I hope everyone got to know a lot more about using or deploying their AI model at scale. So there is one question from Zaire about what is the difference between distributed ML and federated learning. Can you share your thoughts on that?
Hmm. Okay, so when we say distributed computing, so it's like your machines, basically you want to use a lot of different resources and pull them together, and you send the specific or small chunk of data to process on one machine, another chunk of data to process on another machine, another chunk to another machine, and your manager basically collects all the results and give the results to the to the main client. So that's the distributed learning. In regards to federated learning, I'm not quite sure at this stage, but it's another technique of basically learning that your model with huge amount of data, but I'm not sure how exactly it collects the results.
Okay, great. So there is one more question about the steps or the precautions that researcher or we are used to developing research algorithm for our research, and we really don't keep in mind that it might later be need to be used for deployment for production. So, what are your recommendations for students and researchers uh, to keep the factors in their mind when they are developing their um, codes and algorithms?
Okay, so I think let me answer this question and correct me if the question is a little bit in a different way. When we do research, I think for the machine learning, even if you are working in industry, you have to do research, of course, because it's tuning the model is an art. It's like you have to try different techniques, and I think that's research as well. When we deal with the commercial solution, we do not look for improvement in like 0.1% or 0.5%, but in academics or research, people can argue on that the improvement is 1%. So in my opinion, when you do research plus the industry solution, you have to go ahead with a simpler solution, not complex solution. That's for industry thing. And your algorithm has to be understandable for your managers or for your investors or for whoever your client is. And similarly, when you research, that you have to keep in mind that your algorithm has to be simple and it must be understandable to the masses. And I think that by considering that advice, you can do research as well. And of course, when you go ahead with your deployment, you have to keep in mind that your audience is large, is global, and your solution or has to be your pipeline has to be in a way to handle a huge amount of traffic as well.
Okay, great. There's one more question about information leakage. You mentioned at one point in your presentation about that terminology. So, can you please further explain what do you mean by future information leakage?
Okay, yeah, yeah, that's right. That's very important point actually. Where is was that? Okay, here. Okay, so it's when we prepare the data, usually what we do is, let's say, if we want to estimate something and we want to split your training data and future data, so you define mostly windows. Okay, so from this date to this date, this is my training, and from this date to this date, this is my test. So you have to make sure that there is no shift. Usually in pandas thing, when we do this, we just shift one or shift minus one, and sometimes that little shift can add future information. For example, you train your model up till today and you use data from tomorrow, so that model is not going to work, right? Because you have all the information in the future. And uh, every day, if you predict every day, it means you are not predicting, you are just basically regressing your model on that. So when I said future information leakage, I meant that you should not be you should be aware of these things. The best technique is that you basically keep a gap of, let's say, in terms of time series, you keep a gap of let's say 1 day, 2 day, or 20 days, depending on your problem. So that would be best way to basically uh, uh, be aware of future information as well. And in your another practical advice is, when you look at your test data, and if your accuracy is very very high, you should be asking the question. The first question you should be asking is whether my model is looking in the future or not. So that's another practical advice I can give you at this stage.
Okay, great. So I have a personal question. So let me take that privilege. I think this would be our last question for the evening. When looking from a broader picture and the usefulness of AI at scale, what do you think? How relevant it is for with respect to developing economies like that of Pakistan? How can uh, such a developing economy can benefit from AI at scale, learning AI at scale?
Yeah, I think if you look at
So,
the,
what are the applications of relevant application of this?
yeah, I think this is my personal thing, like, and I can give this advice to everyone. Whenever you develop a solution, the scalability should be a de facto in your mind, because without scalability, it's not you can't develop a complete solution. It has to be de facto in your mind, whether it's serving for a small organization or big organization. Your solution has to be scalable. And in terms of application, I think one of the key areas where the AI at scale or machine learning at the scale can be applied is it's financial sector. It's a they have huge customer base, huge client. The data is huge as well. And this is one of the area where AI scale can be applied straight away. There are other areas as well, but on that areas, the data is not being produced at the speed where as compared to the financial sector. So the other areas I can think of which does have great potential in future, that's agriculture thing. If we develop a basic complete solution about data capturing, collection, gathering, and all those things, that could be huge as well.
Okay, there is one last question from Ehsan. He's asking about, should we learn all the steps of the design cycles of AI, or should we just master one step like training model?
Yeah, I think where's that thing? Let me find that slide. Okay. To me, basically, understanding the problem is key. Learning these step is key. Building a model is not a problem. You can use many different already implemented algorithms. The key thing is you have to ask the right question. You have to prepare the data in a right way, ask the right question, go through this cycle, study the cycle and make sure there is no information leakage, or there's nothing missing, or you're not doing anything silly. So let me tell this way: if someone asks me how much time should I spend in training, learning this model training or learning the whole problem solving, I would say your 60% time would be around understanding the problem. And solving the problem is not a big deal. Understanding the problem is a big deal, and formulating in a better way is another key area as well. Yep.
Okay, so I hope Ehsan has got his answer. Thank you very much, Dr. Amjad. If there is one pop-up question again, another question. What is the technique for finding sequence genome using AI? A question from Ahmed Wani, if you would like to answer this.
Sorry, can you say it again?
Yeah, what is the technique for finding genome sequencing? He's talking about using use of AI in genome sequencing.
I don't have any experience with that particular domain.
Okay, okay.
Yeah, but
So,
I can say it could be deep learning most likely. Deep learning would be the better candidate for this one.
yeah, so I think you can find a lot of paper
Yeah.
on genome sequencing from Google. So, yeah, I think that's it for the evening. Thank you, Dr. Amjad. So let me uh, come back to my surprise that I announced at the beginning of this webinar. Yeah, so as a token of appreciation for everyone joining this webinar, Dr. Amjad announced that he will be conducting a 5 to 6 week long course on Spark. So for all of you attending this workshop, there will be we are offering a huge discount just as a token of appreciation for you guys to attend this. If anybody from our current audience is interested in taking this course, please click the link. We are going to send that link in the chat as well. If you can please, if you want to attend this course, I believe it will be a very useful course to attend, keeping in mind the mastery of AI in your future and your profession. This link will be active till 9 o'clock this evening, and I hope that there will be a lot of response from for this course. So with this, I thank you all, and have a very good evening and a very pleasant weekend. Thank you, everyone, and goodbye from AI Lounge. So I'll just keep this meeting for 1 more minute so that you guys can click the link or copy it somewhere. But please do remember that this will be active till 9 p.m. from Pakistan time. That's like 1 hour from now. Thank you, everyone.